All right, we are going to learn about Newton's third law and review Newton's second and first laws today. We've already learned about Newton's first and second laws, but we kind of need a review and to learn how they apply to rockets. Now, we're going to do some rocketry. So, Sir Isaac Newton, this guy was an absolute genius. He contributed to the fields of mathematics and physics. He developed calculus. He was attending Cambridge, Trinity College in Cambridge in 1655 to 56, so a very long time ago. And there was this little pandemic going on known as the Black Plague, and they sent everybody home to keep him safe from the plague. And while he was at home, he got to work and he established the foundations of what would become calculus and some optics principles, and then he developed his three laws. The guy was brilliant. He was an astronomer, an alchemist, a theologian. Like, he is one of the most influential men in history. But usually he's just remembered as the guy who had the apple fall on his head. And this apple tree, it's important, it was at his house. Social distancing was happening. And the apple falling on his head got him thinking about why things fall down. So he also wrote the three basic laws of motion. So the first law says, objects at rest will stay at rest, and objects in motion will stay in motion in a straight line unless acted upon by an unbalanced force. And it's that unbalanced force that's the key. Gravity is pulling on you right now, but the reason that you are not falling through the floor to the center of the earth is because the floor is pushing up on you, or maybe your chair is pushing up on you. Either way, you are not being sucked down into a pit of despair because you've got a balanced force on you. So this is Newton's second law. Force is equal to the mass times the acceleration. It's not just the mass, but the sum of all the forces acting on the object are equal to the mass times the acceleration, which again is why even though there is a force exerting on me from gravity, that force is balanced by the force of the chair, and so I'm not accelerating right now. If you add up all the forces and the forces are not balanced, then you'll have an acceleration. So here we have a cannon. Gunpowder explodes, exerting a force on the cannonball. So cannonballs have a lot of mass, so it takes a lot of force to get them going, right? But then it takes a lot of force to stop them once they do get going. The cannonball has mass, and the force exerted on the cannonball causes it to accelerate. You guys should be pros at this by now. So we can calculate the force using Newton's second law. The force is equal to the mass times the acceleration, right? So whatever the mass of the ball is, times the acceleration of the ball is equal to the force on the ball. So this is Newton's third law. For every action, there is always an opposite and equal reaction. How does it apply here? So the force is exerted on the cannon is the same as the force that is exerted on the cannonball. So if we look at this, it's obvious that the ball is moving forward, but what we don't always remember is that the cannon itself has a force exerted on it in the opposite direction. So why doesn't the cannon go flying off like the ball? And the reason is the mass of the ball is quite small. The acceleration of the ball is quite big. The mass of the cannon is quite large, so the acceleration on the cannon is quite small because the force is equal to the force on the ball. So my husband and I both have handguns, and my handgun is quite a bit smaller than his. Mine's teeny tiny and his is bigger. So when I shoot my gun, which I don't actually like to do very often, there's a huge recoil of the gun pushing back because the gun is so small, and my husband's gun is bigger, so it doesn't push back on me as much because it has more mass, so it has less acceleration. So there's the mass of the cannon. So if we look at this, the mass of the cannon is I looked these up, 3,630 kilograms. The mass of the ball is 27 kilograms. So they're going to have the exact same force exerted on them in opposite directions. The acceleration of this cannonball, because 3,630 is more than 100 times the mass of the ball, which is 27. The acceleration of the ball is going to be more than 100 times the mass of the cannon. So what in the world does this have to do with rockets? Okay. Obviously, Newton's law says rockets cannot accelerate unless an unbalanced force is applied. Which of Newton's laws is this? Newton's first law. Objects at rest tend to stay at rest, and objects in motion tend to stay in motion unless acted on by an unbalanced force. We have an unbalanced force acting on the rocket's going to go up. The amount of thrust or force produced by a rocket engine will be determined by the mass of rocket fuel that is burned and how fast the gas escapes the rocket. So the force is equal to the mass times the acceleration. Which of Newton's laws is that? Hopefully you guys know this. It's Newton's second law. The force is equal to the mass times the acceleration. And then Newton's third law is the biggest one here. The reaction or motion of the rocket is equal to and in the opposite direction of the action or thrust from the engine. And oh, spoilers, I gave it to you. Which of Newton's laws is this? It's Newton's third law. For every action, there is an equal and opposite reaction. So I'm going to go back here. We're going to look at this. So we've got the gases, the combustion gases from the rocket go out in this direction. They apply a force in this direction, and then an equal force is applied on the rocket in the opposite direction. Now, obviously, rockets have a lot of mass, so we need a lot of force to accelerate them, but the combustion of that rocket fuel gives us that force. And so that is how the Newton's three laws apply to these rockets. So when we make our rockets, we are not going to have combustion gases. We are going to have water and air. A water-air mixture, it's a pressurized water-air mixture, is going to come out the back of our rocket. And then that is going to, the Newton's third law, that force in the opposite direction is going to propel our rocket forward. So we're going to want to make sure that our rocket is fairly light so we can have an acceleration, but we're also going to learn tomorrow, I believe, or maybe today, about the importance of balancing the weight on the rocket. We can't just have a super duper duper light rocket because we have some other things we need to deal with. We will do